All right, examples 3 and 4, real-world connections. Rosa can jog 5 miles downhill in the same time it takes her to jog 3 miles uphill. She jogs downhill at 4 miles an hour faster than she jogs uphill. Find her jogging rate each way. Oh my gosh. All right. So we have uphill and we have downhill. We have distance. We have rate. And we have time. And if you remember, distance equals rate times time. Okay? So, in this problem, our distance are in miles per hour, or not miles per hour, our distance is miles. Alright, so she has uphill, she has 3 miles, and downhill she has 5 miles. So those are our distances. She jogs at a rate, okay, we're looking for rate, and we're also looking, we don't know how much time it takes her. So if we don't know how much time it takes her, we're going to let x be the time. We do know some things about the rate though. We know that she can jog 3 miles uphill. 3 miles uphill. So if we have 3 miles, so if you think about this, rate or distance equals rate times time. If I was to get rate by itself, since I said I don't know the time, if time is x, okay, and the distance is 3, our rate then would be, I would divide by x to get rate, so that would be 3 over x. So that's what my rate is going to be, 3 over x. And the same thing with the downhill. I know my distance is 5, my time is x, so my rate would be 5 over x. Okay? That's how I got the rate. Now, the thing is, I know the rate here. Another thing about the rate, it says she jogs downhill 4 miles an hour faster than she jogs uphill. So if I'm going uphill at 5 over x, I need to minus out the 3 over x to equal 4, which would be 4 over 1. My common denominator for this would be x. So that would give me 5 minus 3 equals 4x. Okay? So that would be 5 minus 3, which is 2, equals 4x. Divide by 4, and I get 1/2 is equal to x. Alright, so now that I have 1/2 is equal to x, I can plug the x in, so that means I'm going to plug 1/2 in here and 1/2 here. Okay, I'll plug those halves in, so I got 3 divided by 1/2, which is 3 over 1, times 2 over 1, because remember I changed division to multiplication by its reciprocal, and that's going to give me 6 miles per hour. Okay, and the other one would be 5 times 5 over 1 times 2 over 1, which would give me 10 miles per hour. So that's how I got it. So this would be the downhill right here. This would be the uphill. And that's how I got my rates. Alright, suppose Adrian can weed the garden twice as fast as her son Philip. Together they can weed the garden in 3 hours. How long will it take each of them working alone? Alright, so we have Adrian, we have Philip, and we have togetherness. Boom, boom, boom. Alright, boom. Time. And we have our rate. How fast they can can do it, how long it's going to take them. So, our time, Adrian, doesn't tell us the time it takes Adrian. So we're going to have that as x. Philip takes 2 times that, so twice as long, so that's going to be 2x. And together, we know that, that's 3. Okay? Then it says the rate. Well, just like we were doing before, to find rate, because distance equals rate times time. We don't know what the rate is, but we know our times. Our distance is 1 garden. Okay? The distance for this whole thing is just 1 garden. So this is going to be 1 over x. This is going to be 1 over 2x. And this is going to be 1 over 3. So all of our rates, alright, so from here, they're working together. So we're going to have our rates working together. So we'd have 1x plus 1 over 2x has got to equal 1 over 3. We got to find a common denominator. And that common denominator would be 6x, because we got the 2x, which takes care of the x, and then we have that 3, so 2 times 3 is 6. So our common denominator is going to be 6x. The x's cancel out, leaving with 6. 2x, so 6 divided by 2 is going to be 3, and that is going to equal 2x. Okay, so 6 plus 3 is 9, divide by 2, and we get x is equal to 4.5. So it takes Adrian 4.5 hours, okay, and it would take Philip twice that, so that would take him 9 hours. And that is it.